All right, welcome back. We're going to talk about investigating limits numerically here a bit. Turns out there are lots of limit problems where there just isn't a algebraic trick that'll let you sort of eyeball the answer. Now, there are sometimes more advanced techniques later in the course where you could get the answer, but where we're at now, we can easily get stuck and have no idea how to evaluate the limit. But we can still approximate those kind of numerically. And so here's the typical type of example. Guess the limit as x goes to 0 of sine x all over x. All right. So as I said, there isn't sort of anything obvious just with algebra that lets you rewrite this in a way that the answer is obvious. But you can get out a computer or something and start plugging in smaller and smaller values of x and try to see what sine of x over x converges to, if it does. So we're going to let x go to 0 here, make a chart, putting in smaller and smaller values, and then we'll evaluate sine x over x. So if you plug in 0.1 to sine, you get sine x over x, you get 0.9983334, etc. If you plug in 0.01, you get 0.999983, and then more decimals. And if you plug in 0.001, you get 0.9999999 and more decimals. Now you can plug in more things on your calculator and continue this, but it seems pretty clear that as this number is heading to 0, this one really looks as if it is approaching 1. In fact, this is true, and we will verify this later, but it does turn out that the limit as x goes to 0 of sine x over x is 1. And right now, the only way we have to even approach that problem is this numerical type of approach. All right, ciao.